In the last decades, the tension in the Hubble constant has been growing. Is there physics below of the standard model or systematic effects in the measurements? My name is David Fernandez, and in this poster I present an independent determination of the local value of the Hubble constant, using the correlation between the luminosity and velocity dispersion of the Balmer emission lines, followed by giant H2 regions and H2 galaxies. H2 galaxies are compact massive recent bursts of star formation in FoF galaxies. The optical spectra of H2 galaxies are similar to those of extragalactic giant H2 regions, characterized by a strong emission line with a very low stellar continuum. Normally, these objects are selected by means of equivalent width in the Balmer line, for example 50 Amson in H beta, in order to get an upper limit in the age of the burst around 5 million years, and to reduce the contamination of the underlying older stellar population. Here we can see two examples, NGC 604 and H2 region in M33 and 158. The data consists of high-resolution spectroscopy to measure the velocity dispersion and low-resolution spectroscopy to measure the fluxes. The data were taken in a small telescope for the calibration of the zero point, and the H2 galaxies were compiled from Chavez 2014. The methodology consists of the calibration of the zero point with the giant H2 regions using the fixed slope determined by the H2 galaxies. So we defined the distance indicator. After that, we minimize the chi-square between the observed distance modulus given by the distance indicator as a function of the velocity dispersion and fluxes of H2 galaxies, and the predicted distance modulus given by any cosmological model and the redshift. In each step, we weighted the minimization by the observational errors and included a covariance parameter. Comparing with previous work of Chavez and collaborators 2012, in this work we recalibrated the zero point with new observation, and one of the most important things is that we are presenting for the first time quantitative determination of the systematic errors using H2 galaxies and giant H2 regions as distance indicator. Here the main results are summarized. In the left panel we can see the measurement of the Hubble constant for different combinations of systematic effects and an additional correction by evolution. In the middle panel I show the L-sigma relation resulting from the minimization process with our best value of the Hubble constant, 71 plus 2.8 minus 2.7 megaparsec per kilometer per second. The right panel shows our determination of the Hubble constant and other values derived from the CMB or measuring using different anchor samples for supernovae. The reported Hubble constant in this work included random and systematic errors, and it is consistent with the CMB and supernovae, indicating problems associated with the systematic effects to resolve the tension. The result is the product of an independent approach, and although at present less precise than the supernovae results, it is amenable to substantial improvement, including around 100 giant H2 regions in the local universe, more H2 galaxies, and possible second parameter in the L-sigma relation to reduce the intrinsic scatter. Thank you so much, and here you can find more information.